So let's get into 6.2. 6.2 is called log properties. So 6.1 introduced us to the logs, and 6.2 is going to help us with a bunch of properties, a bunch of things about the log and the logarithmic function. And all of this is meant to make our life easier. So the more we can understand about the logs, the easier it's going to be to deal with them. So we're looking at log properties here, and we've got a couple of them that we're going to use. The first one is called the inverse property. And the inverse property actually has two parts. So the first part says if you've got log base b of b to the x. So let's say that you have a log, whatever the base might be, b, and then inside of it you have another b and then to whatever exponent. Now the thing with this is to remember that inverses undo each other. So if one goes forward, the other one goes backwards. So if you've got matchy-matchy, that's going to cancel itself out, and the only thing that's going to be left is that exponent. And now it's back down on base level. So the only thing you're going to have there is x. So the inverse property allows us to cancel out the log and simplifying things a lot. But it also works the other way. Now the other way is kind of weird to see, but if you have b to the exponent log base b of x, base being b, b being b, bases sit the same, cancel out, and again, we're left with x. And the truth is that any time that you can get rid of a log, if you can get rid of a log and cancel it out, life is going to be easier. Anytime you can get rid of a log is a happy time. So as an example here, let's see, I might give you log base 5 of 25. And now the point is to use this inverse property to solve this. Now I didn't just give you the most basic easy one, I'm going to make you work for it a little bit. So you notice that we have a 5 here, and this is 25. So we can do some rewriting, and could we write this guy as 5 squared? Okay. So if you've got 5 here and a 5 there, those are going to cancel out, and the only thing that's going to be left is the exponent. So this is just a really ugly way to write 2. Okay. But log base 5 of 25, who wants to see that when we could just write 2? Okay? So if you can simplify that, your life will be that much better. And then take that to calculus. If you can work with the number 2 rather than that, life will be way better. I guarantee it, okay? Way better. So that's your first property. Okay? The next ones don't actually, they're more called rules than properties, but same thing. So this next one is the multiplication rule. And it looks like this. If you've got log base b of m times n, so you have two things in the log multiplied together. So we're getting a bit bigger and uglier here. This is the same thing as log base b of m plus log base b of n. So it says it's the multiplication rule, but it actually goes with addition. So multiplication and addition, when it comes to logs, they are tied to each other. Now, I just said that it would normally be easier if we could get rid of logs, and yet I wrote it this way. But most of the time, actually, we're going to have 2 logs being added together, and we're going to use this rule going backwards. So we're not trying to make it uglier, we're trying to make it simpler. So we go the other direction. All right. We'll do some more examples of this in a minute. Let me get these rules up here. So then the quotient rule says if we've got log base b of m divided by n, well, if multiplication goes with addition, division goes with subtraction. This is going to be log base b of m minus log base b of n. look good. Then we have what we call the power rule. And the power rule looks like this. If we've got log base b of m to the n power, okay, so m to the n power, we can pull this n down to the front and do multiplication. So n times log base b of m. So an exponent can be pulled down and become a multiplication in front of the log. And honestly, this rule is helpful sometimes going this way and helpful going that way as well. So we'll use that one both ways to make our life easier. Either way, it makes our life easier. And then we've got two more, I guess, rules, if you want, that we need to be clear on. If you've got log base b of just b, so if the base on the log and the base on, or the number in the log are the same, this is equal to 1. And one last one, if you've got log base b of 1, this is equal to 0. So anytime that we can cancel something out and it equals 1, or cancel something out and equals 0, that's going to make our life way simpler. So let's use these properties or rules here to make life simpler. So let's say that we were asked to simplify log base 4 of x squared plus 3 log base 4 of x. So if we had to deal with this in a bigger equation or something, and we've got two logs, and oh crap, I want to simplify that. So first off, they have to match, base b, that's key, okay? But we've got this addition, and we know that addition goes with multiplication. But there is one little problem starting us off, and that's this guy. Right here in the rule, it does not show us any number in front of the log. So this one's actually going to use two rules. The first thing we're going to do is we're going to use the power rule to pull that guy back up top. So the power rule means we can bring this exponent back up here and rewrite this as log base 4x squared plus log base 4 of x cubed. That makes our life easier. Now we can go for multiplication. Two matching logs, so we can say x squared times x cubed. And then inside there, we can just go with x to the 5th power. Now, you could use the power rule and bring that 5 back in front, but it's not making our life any easier. There's not much simplifying we can do that way, so we can just leave it just like that. But we've taken this from 2 logs down to 1 log. Okay? So that's kind of what we're going for there. All right, let me stick one right here. Let's see what I got here. So let's say that we had something like that. Log x minus 7 minus log x squared minus 49. And we want to simplify this. Okay? We don't want 2 logs, and we certainly don't want subtraction. So we go, subtraction goes with division. No numbers running around. Base on here is 10. So we can rewrite as log base 10 of x minus 7 over x squared minus 49. So yeah, we've got a fraction, but we can even go further with this, can't we? Because can we simplify that or factor that out as x minus 7, x plus 7? And we can actually do some canceling. Boop, boop. So we have log of 1 over x plus 7. Now, still a fraction, still a fraction, but definitely one we can handle. Okay, definitely easier than what we had to start with. Okay, so using our properties in that way. Okay, let's see what else I've got here. All right, what do they ask you to do? They're making your life a little bit ugly here. We just did that. We just did that. Oh, I'm actually asking you to do all that much. Okay, let's see if I can come up with a good one here. Let's say that we had the ln, okay, the natural log of 2x plus 1 plus the natural log of 3x. Just making things up at this point since they don't give you all that much here. Can we combine those two guys together? And we can. So we are going to use the multiplication rule, and we'll go ln, but when we multiply, we got to multiply through, so we'll have 6x and then plus 3x. That one's kind of boring. Sorry about that one. Okay, let's see. How about this one? Oh, let's go the other way. What if I gave you the natural log of e to the 4x times 3x squared minus 1. So this looks like kind of a mess, doesn't it? It doesn't look pretty to me. Even though it's a single log, it really doesn't look all that pretty because of all the multiplication. And you might be inclined to distribute through, but I'm going to tell you something. Remember, natural log and e, they're buddies, right? So this would be one where we actually want to pull it apart. So we actually want to use addition to write this first one as the ln of e to the 4x plus the ln of 3x squared minus 1. Now it looks uglier because we've got 2, but what happens here? That guy actually cancels out and leaves us what? Just 4x, right? So we are now back to having just one natural log in the problem, and what's in the natural log is actually simpler than what we started with, okay? The natural log up here, it looked ugly. We could simplify the front half and just 4x, that's not bad, okay? If they ask you to plug in 2, you can plug in 2 or whatever. Okay, so we simplify back to one log, and the whole thing is just a little bit easier for us to deal with. Okay, so log properties, they're going to ask you again to simplify things, and we'll do more log properties in the next section and the next section after that. But now is the perfect time to take a break because we're not done with 6.2, but the next properties that we're going to use are going to use our calculator. So if you do not have your calculator near you, it's time to get your calculator, and your calculator needs to have the logs on it. So it needs to have log and ln on it. And for most calculators, the log and the natural log are along the left-hand column there. So that's what you're looking for. So go find that guy, and then it's time to do the next lesson. Okay?